Hi everyone, I'm Dr. Darlik Silvi from Raniana Government College for Women, Tirunelveli. So our college is a big campus consisting of 40 acres of land. It has new buildings, old buildings, with lot of infrastructure with library facilities and lab facilities. Every science department is having their own lab. Apart from that, we have number of computer labs also for the students to upgrade themselves. So, as on date, we have 4,290 students in our college studying in various capacities. We have 13 PG courses, we have 15 UG courses, 4 MPhil courses, and 10 departments are upgraded with research department. So, let's explore the basic concepts of statistics now. Hello, I'm Darling Sylvie, Assistant Professor of Commerce, Raniana Government College for Women, Tirunelveli. Today I'm going to teach you the choice of statistical tools and its implementation. So let me brief the contents of today I'm going to teach today. The first point is identify the variables. The second one is check for normality. And the third is choice of statistical tools. So let's start with identifying the variables. Variable means any observation that can take on different values, for example, age, gender. Attributes means a specific value on a variable, the value assigned to the variable. For example, if age is 20, 25, gender means male or female. So like that, a specific value or on a variable, if it is assigned, it is known as attributes. The second portion is, see, this is an example of variable age. Attribute 18, 19, 20. Next example of variable gender. Attribute is male or female. So this is numerical and this is in words. That is, this is quantitative phenomena and this is qualitative phenomena. Let me start one more type of variable. So satisfaction, it is measured in the form of highly satisfied, satisfied, neutral, dissatisfied, and highly dissatisfied. Again, we should understand what is independent variable and what is dependent variable. So, independent variable is exercise participation which result in health status, change in the attitude, social support, and intervention. So, due to this exercise participation, the reflection is all these things. So, most probably independent variable is the single one and dependent variable is the number of items. Okay, so this is the cause, the reason for all these things. And this is the effect. Okay, so this is the identification of variables in different form. So data, this can be explained in two aspects. One is numerical, another one is categorical. Numerical means it is made up of numbers. Again, the examples goes like this: age, weight, number of children, shoe size, etc. Under categorical, it is made of words. That means eye color, maybe blackish, brownish, bluish, like that. Gender, male and female. Blood type, O positive, B positive, B negative, AB positive, negative, like that. So again, this numerical data can be categorized into continuous and discrete. Continuous means it has infinite options: age, weight, blood pressure, etc. Under discrete, it comes within the limit, that is finite options. Shoe size, that not goes beyond 9. Number of children, that not goes beyond 10. So like that, there will be a limit for that. So that is discrete, and that is the difference between discrete and continuous. Under categorical variables, again we have the division of ordinal and nominal. Ordinal, the data has a hierarchy. The severity of the pain, suppose excruciating, mild, so like that it may vary. And the satisfaction rating, the example that I have cited earlier, mood, that is depressed mood, stressed mood, relaxed mood, like that. Also, the hierarchy will be there. Under nominal, data has no hierarchy like that. So we can put it as it is without any deviation. Eye color, dog breed, blood type. We can say it exactly. So that is nominal. So this is the basic thing you need to recognize and identify. Again, the levels of measurement goes like this. Nominal, only we are naming the variables as such. Under ordinal, beyond naming the variables, we can order the items. Okay, we can rank the items. So interval consisting of named plus ordered plus proportionate interval. And then ratio consisting of named plus ordered plus proportionate interval between variables. It can accommodate absolute zero also. That means in case of Fahrenheit, suppose that can be made into zero. Zero value is possible under ratio. That's a differentiation there. So on levels of measurement consisting of nominal, ordinal, interval, and then ratio. Again, one more classification. So we can classify the variables into parametric and non-parametric. So under assumed distribution, parametric, it's normal, non-parametric, anything and everything can be covered under this area. Then assumed variance, homogeneous and heterogeneous, both can be considered here. And then typical data, ratio or interval, ordinal or nominal. And then data set relationship. Parametric is independent, non-parametric can accommodate both. Then usual central measure, parametric mean, non-parametric mean. So that is the basic criteria of statistics. Then with regards to the benefits of parametric, it can draw more conclusions. So we can saturate the data, we can give conclusion. And then in case of non-parametric data, it is very simple, less affected by outliers. So this is the way in which we can convert the categorical data into numerical data. So categorical data is given in the form of text format. So with the help of mapping, which is otherwise known as coding, by giving codes to these things, so we can convert it into numeric format. Okay, so here in this example, Toyota is given 14. So in the place of data, 14 is given. Okay, can you get the point? And then Ford is given as 27. The word Ford is given 29 as value. So whenever Ford is applicable, it can be replaced by the number 27. Okay, then Mercedes. So it is given then number 18. So instead of using Mercedes directly, we can apply or we can specify it with 18 here. So this is the transformation of variables. That means the text format can be converted into numerical. So then the next aspect, the second aspect of my content, check for normality. First we shall begin with a single variable. So go to analyze, descriptive statistics. This is the output of SPSS format. Then go to explore. You will get a dialog box like this. Okay. So just transfer the variables into dependent and independent. So here independent list is given as factor list. So you can import your independent variables into this box. Then enable under statistics. First enable statistics. Within that enable descriptive. So you can enable whatever you want. We have M estimators, we have outliers and percentiles also. And then under the second category, see plots are available. Under plots, you can enable stem and leaf, that too not most necessity, histogram, then normality plot. These two are being most essential one. And then comes, this is the output. Okay. So under output, how can you find whether it is a significant or not significant one? So this is the case. Okay. If the values are more than 0.05, you can take it as the normal one. Otherwise, it can be rejected. Okay. Otherwise, it will be considered as abnormal one. So this is another exaggeration of the data. So we will get a line like this. So if the spotted data goes along with the straight line, this is the normal one. We can accept it. Okay. If it is scattered all over this area, it can be rejected. Then check for normality for multiple variables. More than one variables can be tested. So these are all the variables entered in connection with the scaling technique. That is agree some more, disagree some more, undecided. So like that the values are being arranged here. Now we can check the reliability of these data with the help of scaling technique. So now go to reliability scale and then reliability analysis. You will get a dialog box like this. You'll get only the statistics as the additional one. So export data from the left to right. You will get this one. Okay, click statistics. You'll be given all these things. Enable the items that you need here. Item scale if item, then you will get correlation. You can also go for F test here to find the significance of the test. Okay, so you will get this output. This Chromebug alpha, this is 0.805. Okay, number of items taken together is 9 here, and then you will get one more output like this. So here you can find the reliability of the data. So how we can interpret the data? See, in the Chromebug alpha, if it is 0.6, it is noted as poor. If it is between 0.6 and 0.7, it is moderate. If it is within 0.7 and 0.8, it is treated as good. If it ranges between 0.8 and 0.9, it is considered as very good. If it is above 0.9, it is excellent. So this is the way in which you can interpret. So in the given example, it is 0.805. So it comes under this category, very good. So we can very well proceed with this thing. So here the value is 0.744. So which is good. Okay. So here we can have the possibility of removing the items. So how to remove it? This corrected item total correlation will help us to remove the outliers. See the value of correlation or magnitude of correlation is very less in these two cases. The highlighted cases 7 and 10, 0.247 and 0.201. So these can be get out of our purview of analysis. Then we can automatically this Chromebug alpha value will be increased. So there are two items numbers 7 and 10 which are rather low item total correlations, and the alpha would go up if they are deleted or dropped out. Okay. Now coming to the third aspect, choice of statistical tools. See, this is the type of analysis, univariate analysis. That means the first item is univariate analysis. So that consists of uni stands for only one. So univariate analysis deals with a single variable. Okay. Now coming to the second part, that is bivariate analysis. This deals with two variables, x and y. Okay. Now comes to multivariate analysis. So n number of analysis are possible under multivariate analysis. More than two variables can be analyzed with the help of this multivariate analysis. So this is the example of univariate analysis. So we can have mean, median, mode, geometric mean, harmonic mean, etc. Coming to the bivariate analysis, so we have two: simple correlation and then simple regression. Simple correlation and simple regression. So if we go for this, explanation of simple correlation, we can find there is linear upward. If it is upward in the upward direction, it is known as linear upward correlation. If it is going downward, it is known as linear downward correlation. So in the same way, we can go for this simple regression also. So if it is within the dotted plots are within the straight line bounded area, it is okay. If it is scattered all around, so we can ignore it. Okay, so this gives the interdependency of the variables. How, to what extent x depends on y and to what extent y depends on x will be explained with the help of diagram here under the simple regression. So under simple correlation, it gives the degree of relationship between two variables. Are they strongly related or weakly related? The degree of correlation is expressed in terms of simple correlation. Okay. Now coming to multivariate analysis. So factor analysis, which helps the reduction of so many data into different simple components. Identifying and naming the components are playing vital part in case of factor analysis. And then comes ANOVA. This is analysis of variance. We have two types: one-way ANOVA and one-way analysis and two-way analysis. Then comes t-test. Normally we use it for simple sample, one sample, two samples, paired sign test, etc. If we have n is less than 30, okay, the same can be applied if the n is more than 30. So 30 is the parameter to be followed. Large sample is more than 30, small sample for less than 30. Okay, then multi-correlation. So whenever we have more than two variables, we can very well go for this multi-correlation or multiple correlation. Okay, then discriminant analysis. This gives differentiation of various items. This is more or less equivalent to this factor analysis. And then we have multiple regression also. So when we have x1, x2, x3, y1, y2, y3, so like that we have number of variables, we can go for this multiple regression. Then comes Mann-Whitney test. This is purely a non-parametric test, and this can be applied when we have two number of samples. This is otherwise known as U-test. Then Kruskal-Wallis test, the same type. When we have more than two variables or two samples, we can go for this Kruskal-Wallis test. This is otherwise known as H-test. The next is cluster analysis. This is helpful for grouping of items. When we have n number of customers, to study what type of customers exactly they are, we can apply this cluster analysis. Chi-square test, that is common for both parametric as well as non-parametric test and widely used in research. Then MANOVA, which is ANOVA for analysis of variance. This MANOVA stands for multiple cases. So these are just a list of multivariate analysis. We have number of items more than this. So now choosing above the statistical tools, choice of statistical tools, it relies on two aspects. One is descriptive statistics and one is inferential statistics. Just to exhibit the nature of data, we will follow this descriptive statistics. Just for description, we will be following this descriptive statistics that can be done with the help of frequency tables by exhibiting the measures of central tendency, the components of measures of central tendency known as mean, median, mode, geometric mean, and harmonic mean. And we have measures of dispersion also, that consisting of range, which is the difference between minimum and maximum values, and then standard deviation, and then confidential interval, and then we shall go for quartile deviation, mean deviation, and the skewness, kurtosis, everything is available here. Okay, then this is with regards to the descriptive statistics. If we would like to go for inferential statistics, that means how we are inferring from the population, how we are taking the sample, how we are inferring. So that is inferential statistics. So we can step into the next portion. Okay, this is inferential statistics. To compare frequency tables, we are using chi-square test. That will give us the goodness of it as well as the contingency table test. If we want to go for to find the relationship between variables, that is two variables, we can go for correlation analysis. If the data are quantifiable, we can go for Pearson correlation. That will give us the answer. And if the data are that are of the type of ranked items, we can go for Spearman rank correlation. Attitudes can be measured. And then regression analysis. Okay, again we will study the interpretation as well as extrapolation with the help of this regression analysis. Okay, so this is with regards to comparison of two variables. If you want to compare more than two variables, so this is the item: parametric test, t-test. Okay, to compare two variables. Non-parametric item, we have Wilcoxon ransom test. This is for the independent population, and the Wilcoxon signed rank test. This is for the dependent population. So we know the meaning of what is dependent and what is independent. Accordingly, we can apply this test. Okay. In the same way here, t-test, mean and standard deviation, descriptive data is also available here. And then pooled estimate of variance, t-test independence population, and paired t-test is applicable for dependent population. Then to compare more than two variables, parametric test, we can go for discrete data when n is more than 40. First checking it for congruence test. If it is significant, you can go for ANOVA. If the result is not significant, then also you can go for ANOVA. Okay, so under both the cases, we can go for ANOVA. Okay, you can manipulate the test if it is okay. Then for non-parametric test, critical values test and man-Whitney test will also be applicable. Okay, so if it is significant, you can go for Turkey's non-parametric test. Okay, so critical values test for more than two variables, and if it is only two, we'll go for man-Whitney. And if it is okay, if it is significant, then we can proceed with Turkey's test also. That too available in the same dialog box SPSS. So here we can pursue the application of statistical tools in a different perspective. Okay, so in the predictor variable, if it is categorical, in the sense that if it is non-numerical. Okay, if it is non-numerical, what about the outcome variable? If it is again categorical, only chi-square test. If it is quantifiable, or the outcome variable, we have converted the categorical variable into numerical variable, do a comparison. So how many groups? If it is 2, t-test. If it is more than 2, again outcome variable, if it is 1 ANOVA, more than 2, we can go for MANOVA. Then comes to quantitative. That means quantifiable items. Items expressed in terms of numbers. Outcome variable, categorical, quantitative. If it is categorical, which is very rare, then go for logistic regression. If it is quantitative, again check the outcome variable, okay, or predictor variable. So if it is 1, simple regression. If it is more than 1, go for multiple regression. So this is based on the categorical and quantitative data. Okay, so now one more attempt with regards to the parametric and non-parametric test. If your variables are being parametric, that is distribution free and assumption free, you can go for this one sample t-test, z-test. If it is again for t-test for less than 30 and z-test for more than 30 sample size, then if it is 2 samples, again independent samples, 2 group t-test, z-test, then paired sample and paired test. So these are all the items. Okay. Then if we go for the non-parametric test, 1 sample can be done with the help of chi-square, Kolmogorov-Smirnov run test, where we will express only the signs, then binomial also. Then for 2 samples, we again categorized into independent sample and paired sample. Independent alone. Paired sample means we can get the data in pairs. Okay. Then we can apply chi-square. For independent samples, we can apply chi-square, man-Whitney, median, then Kolmogorov-Smirnov. Then for paired test, we have paired samples, we have sign test, Wilcoxon test, then McNamara test, and then chi-square. See, this chi-square is widely applicable in all the cases and a very popular test, chi-square is. Okay. Thank you for your patience listening. Have a happy learning. Thank you.